Good evening, dear colleagues, and I hope I can be heard from your
Yes,
end. I hope I can be heard from your end. All right, thank you, Vida, for the confirmation. All right, so we are going to start our first lesson on DCIT 201, programming one to be specific. And before I start, I always like to ask that the lecturer you introduced us to some IDEs that we have to download. Even if you have not installed it yet, I think by now you should have done the downloads. Yes, we will not be using it in our first lesson today because today we are just going to understand certain things, as he said. When we meet, he will take us through the explanation. He can use just one, like what he said. Okay, you will just give the explanation. We just jump into the coding environment. So to be honest, if I say at least you should download this IDEs that he spoke about, starting from the is it in Intelli, then PyCharm and so on and so forth. So you should download them. It's a friendly advice. And on the latter note, too, it also takes some it's a heavy it's a demanding what do you call it application. They are all coming in very huge sizes. So I also advise that if you do the downloads, do it like at the time when your network can do the downloads as well, so that you not find yourself wanting during the lecture time that you can't do downloads. You know how to distort the network and your lecture and all. So please do the downloads beforehand. Okay. So first of all, I prepared some slides that I'll be using to teach alongside his. I don't know if you have downloaded them. They are also on Sakai. You can also download the resources and use them as well. Okay, so kindly give me a moment. Let me share my screen so that we can start today's class. I hope my screen can be seen from your end. If so, please kindly give me a thumbs up so I know that my screen can be seen from your end. All right. No, thank you very much for your reaction. I'm indeed grateful for that. Those who I'm not seeing any reaction from doesn't mean that you can't see my screen. I can't teach for like 1 hour then say I didn't see anything to really worry me. So if you can see my screen, can you react for me? Okay. Joshua Champon, so thank you for the reaction. At least two people have reacted, so I know that my screen can be seen, so I don't have much of a worry. All right. So let me open this document up so that we can have a look at it. Uh, Moment. Oh, it's taking quite a long time to open. Hey, it has still not opened up. Let me check it up again. Let me first try and save it and see this. So my machine, but I've forgotten where I saved it. Let me just save it on the desktop and see. Just open it from there. Oh, I think it has opened already. So, okay, so we are going to start to learn today's slides. Welcome to DCI 2201 Programming 1. We are going to learn about some fundamental concepts. Okay, so I'll be working, as I said, I'll be working alongside this presentation and the one I made for this class as well. So in case you see me switching between these two things, don't be too confused. That is what is going on. So give me a moment. Let me also load my, this is number basis. But this one go to. Okay. I guess I have to open it again. Okay, so today we are going to talk more about Java. So let me open Java. Mhm. I want to talk about the OOD, OOA, etc. But there is on some part of my slide here, and I'm trying to get to it. So kindly give me a moment. But we can start with the one that was given to us by the lecturer. Okay, so we are saying we are going to learn the fundamental concept as of OOD and OOP. Okay, at the end of this section, you should be able to explain how a software design may be represented as a set of what interacting objects that manage their own state and operations. We should be able to also describe the activities in the object-oriented design process. That is the activities involved when we are talking about object-oriented design. We should also be able to introduce various models that describe an object-oriented design. So we are going to use the various models that are available out there to explain object-oriented design. And we should be able to show how the UML, okay, may be used to represent these what models. So don't really worry yourself about most of these things. Okay, in case you're wondering what a UML is, it's a unified modeling language. Okay, so we are going to look at all these things and we are going to get, you can stop me at any point in time by raising your hand in case you don't understand anything, so that we go through it. Okay, and our friends are still trying to join. So in case somebody sends us back, let's be a bit relaxed on the person. I know how sometimes you are going for it and somebody sends you back. It's like, so let's be patient for them as well. So first of all, before I will start, who can this one? I normally don't get anybody to say anything, but I'll still ask who, in his or her own knowledge or an understanding, can explain from our or can say something from our lecture before what object-oriented analysis, designing and programming are like, how they are related and how they are also distinct in some way. I'm sharing the information on the screen, but you can also give a further explanation to if you have any understanding of it. Joshua, please help me with those that will raise their hand, since my eyes are on the content instead of this place. So please, if anybody raise their hands, please prompt me. Okay, sorry, I'm back. I've been talking for a while now. I've not noticed that I'm muted. God, please have mercy on me. Okay, so Joshua, please kindly help me. When somebody raises their hands, please kindly prompt me so that I'm able to attend to the person. And as well, I'll be asking questions. Let's make this class interactive as possible. We know how being interactive will make the class nice. If we are all just there like that and we are not saying anything, it will not make the class nice. So please, let's try to be interactive. When I ask of your point of view or what you have to say, can you come out with it? So any corrections and any directions can be also placed forward. So I was talking about, I didn't know I was muted. Okay, forgive me. Um, we are going to talk about object-oriented development. Okay, and object-oriented development has to do with object-oriented analysis, OOA, object-oriented design, OOD, object-oriented programming. They are all related, okay, but in either ways too, they are distinct in their own ways. Okay, so what is object-oriented analysis? It is concerned with developing an object model for the application. Let's focus on this particular word here, model. Okay, model. When in your basic level, probably in mathematics also, okay, when you're creating a model of something, how do you understand model? Because I'm creating a model of something. Anybody to help us with the understanding of the word model in his or her own way? Anybody? Okay. For a moment, I thought I was muted again, but I'm not muted again. Please, can I be heard?
Yes, please. You can be heard.
Oh, okay, I can be heard. Okay, Abuaje Print, if I mention him wrong, please can you unmute yourself and let us know of your I explanation to what model is?
Yes. So what I can say is model is like a blueprint, or you can say a dummy or a demo of something.
Very good. And that is a perfect explanation to it. Who also can add his or her bit on what a model is? More hands, please. Yeah. Okay, all right. So Abaji Prince, thank you very much. I'm not getting any more hands, so let's work with what you said and what I'll also add to it. Okay, so looking at the word model, okay, model is trying to represent something in a way, in a let me say in a diagrammatic way, or there are various ways to model out something. Okay, maybe physically you can try to use objects, okay, to try and make what you are talking about or what you are trying to say like represent it in a way that people can relate easily, okay, by using items or even sometimes a sketch, as I said, a blueprint. Okay, so object or oriented analysis, okay, you have to definitely, if I want to create something, I don't know how many people have related with architects before. Okay, if they want to create something, they make a model of it. Okay, then they look at what measurement of this will fit into this and what this, then they create the item, model it in such a way and present it. Okay, then they pitch what they want to develop. Probably they need financial help, whatever, but people have to see or try to understand what they are going to build, okay, and what goes into what they are going to build. So object-oriented analysis works in that manner. Are you okay? This analysis, remember when we were learning C++, okay, first of all, you have to identify the problem, okay, and this identification of problem and all has to do with analyzing the problem, okay, so this is a one way or the other related in the sense that creating a model, when you're creating a model, you are definitely going to come across problems when you are creating it. Something is not going to work. You are going to find means and ways to make it work before the actual structure is placed into reality. A modeling must be what? Made. Please, I hope understanding has been carried forward. If so, can I guess that maybe time's up or something? Please, reactions are very, very important to me when I'm teaching. Okay, if not to, if I don't see anything, I know that I'm just talking to myself. Yeah, okay, thank you very much. So we can continue since I've gotten a reaction, we can continue. So that is for the aspect of object-oriented analysis. Okay, what about object-oriented what? Design. This is concerned with developing an object-oriented system model. Okay, the first one was what? Developing an object model of the applications domain. This is developing an object-oriented system model to implement the requirements. Okay, all right, so let me say I've created the model, the structure. But what actually goes into creating a structure? When we say we are designing something, okay, I want to create a model. Fine, the model, what is it going to be? It's going to be maybe a structure or a school. Let me say I want to build a school. Okay, then I have to know what goes into the design of the school. I don't know if maybe I'll need maybe 6 iron rods for one pillar because of the height of the school I want to build. Okay, designing is one thing. Designing is one thing. Modeling is another. Okay, even though one, as they always say, as the previous slide said, they are all related in some way, in the sense that they follow suit. Okay, they all depend on each other for the thing to actually work. Okay, but in one way or the other, they all have their own roles that they play. Okay, I see a hand up. I see a hand up. I see a hand up. Please, you can unmute and speak.
Yes, please, you said uh modeling is one thing. You said something like that. Modeling is
Yes,
one thing
please.
and something is the other.
And
Please, can
design.
you repeat that? I want to ask a question about
Yes,
that. You said modeling is
yes.
one thing and then
Modeling of something is another. Yes, as I said, they are all related in some way, but modeling something actually is different from designing it. And if okay, you ask a question, let me see, so I can assist you.
okay, so I think I have it now. I didn't it's fine. It's fine. You can continue. Sorry.
Okay. All right. So what goes into designing and what goes into modeling, and why are they related but they are different in their own ways? Okay, as you said, modeling something is creating a what? A blueprint. Somebody said, I don't know if it is you, and or trying to put the item into reality, okay, using objects and things. Okay, that is we are trying to model. We are modeling the thing. That when you have done with the structure, you have created a model of it. Okay, but what went into this side of the structure, you have to design it. Please, I hope you are getting what I'm saying. Okay, if I'm modeling something, I'm creating a thing. The process, let's take I have a clay in my hand. Let's go to that basic level. I have clay in my hand. Okay, I am modeling the clay. What am I modeling it? Don't I have any particular design I want the clay to assume? I hope you are getting what I'm trying to say. I should have a design I want the clay to assume in order to achieve a particular shape. I wanted to follow a particular design. Maybe I should roll it in my palm. It should assume a particular shape. Then the modeling of it begins for me to achieve a particular what shape. I hope like people you can relate to what I'm trying to say, or we are on the same level here. Okay, so this you see that the sentence starts with it is concerned with, it is concerned with. Okay, they are all related because at the end of the day they come together for the structure to stand, okay, or for the structure to be complete. But each part plays an is important role. So object-oriented programming on the other hand is also concerned with realizing and ODD using what? OO programming languages such as Java. So let's bring it to the programming level. Okay, I have something I want to code. What am I going to code? What am I going to produce? I don't know what program am I producing. These things we have said of it in C++. Okay, like what am I going to produce at the end of the day? Okay, I want to create a system. This system is supposed to help somebody at maybe a shop, okay, attending to people, receive first of all the names of the people that enter the shop, okay, their items they bought, the prices of the items, and produce a total, if possible as well, produce their balance for them. Are you okay? And all of it printed by this program onto a piece of paper. Okay, I have said what I want to see, or how what program I want to see, then what goes into building that program. One, OOE. Okay. Yes, at the end of the day, the program should be modeled. How should it look like? What should the interface be like? Okay, what buttons am I going to use? How is the program going to logically process the input of a user? Do you understand what I'm saying? Then object-oriented design goes to, okay, the button, where should it go? Should it be at the left? Should it be at the right? Should it be on top for easy access? Should it come down? I hope you are getting what this interface we are looking at right now for Microsoft Teams, okay, for PowerPoint presentation. This file tab here, okay, could have been down here somewhere. It all goes into the design. Okay, but at the end of the day, what code, which is the object-oriented programming, what code made this particular button possible? What code made this home tab possible? This insert tab possible? The design talks about, okay, it should be here. It should have a line under it. When I touch it, the line should expand. That is design. Modeling is at the end of the day, everything is flat. It's on the surface. Are you okay? This is how it's supposed to look like. This is how it's supposed to look like. But designing is at the end of the day, it should be here. It should be here. It should be here. That's what goes into designing something. And I think our previous understanding of designing, analysis, problem solving and things will also give us a fair idea of what I'm trying to say. I don't know if you get what I'm trying. If you have any question at this point, you can ask. Okay, so first of all, let's look at what an object is. What is an object? Objects are entities in a software, okay, which represent instances of real world and system entities. Okay, so they are entities in a software. Remember, we are programmers, okay, but they represent something in real life. Are you okay? But at the end of the day, the object is in a software. Okay, not in real life. That's why it's using the word represent. If you have a class prefect in a class, okay, and then the class prefect is absent, definitely the assistant is going to serve as the representative. That does not mean that the assistant is the class prefect, the main class prefect. Are you okay? The assistant is just representing in the absence of the main. Are you okay? Yes, he or she can act as, but it's not. Do you understand? No reaction. Okay, let's go on. Okay, thank you very much for the reaction, Vida. I'm very, very grateful. Now, let's look at this sentence here before we look at what it's about. They said object classes may inherit attributes and services from other object classes. When we go into the code, okay, I'll be using these terms. And when we meet them and we are actually coding, and I'll say, what is an object class? This is an object. This is how to type an object class. This is what it does. What this is a class. When I say a class, we have all been to school. You know, we are even in school as we are talking right now. You are belonging to a particular class. Okay. There are certain things you are studying in your class. Okay. That makes you qualify to be in that class. It's also understand the fact that even though it qualifies you, it denies something else from entering that class. The same way to what you might be inside in that class might also allow another person in another class to be in that class. That is why for some reason we found ourselves having a course we are studying. People are not IT students, but they are studying that course. For instance, UGLC. So we can be many in a UGLC class, but that does not mean that we all belong to the same class. There is something that we have inherited from, we have in common that makes us like one way or the other related, but we are from different classes. Okay, so when I create a class in Java, okay, and then I create another class, but I need something from the previous class that they have in common. Okay, probably a button that both of them should have, or some function or some operator that both of them should be using, or probably something stored in the memory that both of them will be fetching from. Okay, that is an attribute that has been inherited from both classes. Okay, so we will learn about all these things and we appreciate it much better when we enter the coding environment. Okay, so I'll call upon somebody to read this interface for me. If you are willing to, you just unmute and read. Okay, I want to involve you guys in the lecture.
So far, we started our program by decomposing tasks into methods. Please, should I read off?
Yes, please continue. Read everything.
This is excellent practice, but it is difficult to understand and update a program that consists of a large collection of methods. To overcome this problem, computer scientists invaded object-oriented programming, a programming style in which tasks are solved by collaborating objects. Each object has its own set of data, together with a set of methods that are upon the data.
Thank you very much. Okay, God bless you. Let's appreciate what I did. It's related to what I said previously. Okay, as I said, okay, we can all be in one class at one particular lecture. Let me be specific, but we might all not be studying the same. We might all not be this as IT students. Okay, for instance, I set an example that UGLC. Okay, the fact that we are all in that UGLC class does not mean that we are all IT students. As far as I knew, to my capable knowledge, I knew that it was a course that was supposed to be offered by everybody. Do you understand? So we can find other people in psychology, business administration, or studying UGLC. Are you okay? So one way or the other, object-oriented programming has made this very easy, because if I'm supposed to create a particular program that is going to work or cut across all these different group of students, okay, object-oriented programming says that don't create this class for this with this object inside, then come and create and pretend like as if the previous one was not existing when they hold some similar attribute to which you can just link together for them to have something to do in common. Please, are we following? So if I say UGRC, I'll come and create IT, then I'll create UGRC strictly for IT people, like as if we are studying something differently in our UGRC than somebody. Like then we are going to create business administration. You just like at this point, if I have to make certain updates, okay, I have to go and update for IT students. I have to differently come and update for business administration, which makes it difficult. You understand? It makes this method difficult for or the task difficult to achieve. But if I have linked everybody to just this one thing and I create an update, it affects everybody at a go. Please, I hope you get how this thing is applicable in real life. Okay, so object-oriented programming came to solve that problem. First of all, first we used to create this one for this one for that, this one for this, and we have to update individually, like Sakai. Yes, we are all different students, but we are all on Sakai. So when an update happens on Sakai, it affects all of us. It does not affect some people, even sometimes lecturers. I don't know if you have noticed. Even sometimes, oh, there's an update going on Sakai, so you are not able to access it at the moment. You understand? Even though he's a lecturer, at the end of the day, we are all linked to the fact that we are all using a platform to run our processes. So when an update is going on, it's not going on for only students. When an update is going on, it's not going for only lectures, and that is all. Okay, it affects us all. The interface affects us also. When a lecture opens this or an interface, yes, there are some buttons or two that are reserved for only lectures, like turning on certain buttons, enabling things, and doing that. But generally, you can see what is going on. That some of them look like ours, like sites, home, site info, those kind of things. Please, I hope you understand. So when an update is done for certain things like that, okay, I want to make an announcement. Okay, the announcement button move from here to here. When update is done for that announcement button, okay, it affects everybody, including the lecturer, because the lecturer will put the announcement there. We will also go and click on the announcement, read what is there. So the position on the announcement button changes for everybody, and we have to cope with it. That's how object-oriented program. That's what I mean by object-oriented. The object is being oriented. When we say something is oriented, it means its position. Okay, so we are programming an object and orienting it in such a way that, okay, even though we are all different people, we can all bend or we can all see its different orientations. That is assumes. Okay, due to the programming that we are, because one way or the other, we are all linked to that particular thing, even though we are all different what objects. Please, do we understand? If any question to you, can stop and ask. I'm proceeding. If no question, I'm proceeding. Okay. Thank you for the time, sir. Object-oriented programming. Let's continue. When you develop an object-oriented program, you create your own object that describes what is important in your application. For example, in a student database, you might work with students and course code objects. These objects then must be what? Supplied with methods. In Java, for example, a programmer does not implement a single object. Instead, the programmer provides a class. Okay, so I can't create an object for what do we call it? Course code, and I come and create object for students, students ID, object for this, like separate, but I can create a class and put all those things inside. Then if you find yourself in that class, you benefit from one particular like you pick one attribute from the class, then you fall inside that, but you're a different entity. So I'll teach you how to create a class, work with different, and then call upon the class and what has been placed inside the class specifically to for that particular entity to benefit from the class. Okay, and that entity outside the class becomes an object. What is inside the class is like the attributes and things that both all of them will be needing. Then you just be fetching from the class who will need this one, who will not need this one. And it's really, really interesting if you think about it. Okay, a class describes a set of objects. As I said, it's a set of objects, okay, that are going to be needed. So I'll create a class, puts this set of objects with the same behavior. Whereas what I said just came, they must have the same behavior. Okay, for example, the string class attribute describes the behavior of all strings. Okay, so anything I will put inside that string class, okay, must be whether if I put, we learn this thing in C++, if I put a number there, as long as I have named that class as a string, everything that exists there becomes a what? A string. Whether I put a figure there or digit, it becomes a string. So if I need it to work as a number, I have to work it outside that class and say, okay, when you leave this class and come here and enter this particular object here, okay, change from being a string to become a number. Please, are you following? In the class, it's a string, yes, but when I call upon it in another place, I can, is it what, explicitly change it from being a what, a string, okay, into a number, so I can perform some mathematical calculations with that thing. Okay, you are a string in this class, but when you move to a student's ID, become a number. You are a string to a lecturer as maybe A plus, but when you move to the student's ID to be in the student's ID for the score of a student, become a number that will contribute to the student's GPA. That A plus to a lecturer is just A plus, it's a string. But when it moves from your interface and enters your interface in a different class, what changes? It becomes a number. It represents a particular number that contributes to that addition or division or whatever of your GPA. So the student, the lecturer will just enter A plus. He does not really care about A plus being maybe 1 point this or 2 point that, because when he moves from his class to your place, okay, it changes to what you need it to become. By the end of the day, we are all belonging to a particular stated class. I hope it's understood. So they said the class, for example, okay, I've said that. They said the class specifies how a string stores its character. Okay, very good. Which methods can be used with, am I reading it? So, okay, which methods can be used with strings and how the methods are implemented. Are you okay? So as I said, lecturer will enter A plus at his end. For him or her, he has entered or she has entered A plus. But when it moves from that particular class and enters your student class, okay, that A plus becomes something else. It's implemented differently. You understand? Because of the class I have created for you and I place you there. The class I've created for the lecturer is different. But at the end of the day, I've created a general class that, okay, we are all having a similar something. The lecturer enters from his end into that class, it's an A plus. But when you go into the class to fetch your grade, it's a number. Do you understand what I'm saying? It's a string. When you go from your class and enter then this makes what? Update very easy. How? Because if I want, at the end of the day, if I want that lecturers entry of just a string A plus should also be a number, the lecturer should know that this is what it means. This is what must I do? I must just change that general class that we are all fetching from. When I change that, it affects everybody. And that's what object-oriented programming is. Okay, so lecturer enters from his end. A plus, when it goes into the general, it is converted there as a number. Lecturer see that, okay, it is a number. Student goes and picks it and it's still a number. Please, do you understand? Okay, let's go on then. Abstraction. What is abstraction? Some of these terms are there. We just read through them for getting familiar with the certain set the terms used. Okay, but when we enter the coding environment, we are going to appreciate these things more when it's practically being done. Okay, so what is an abstraction? I think I've jammed that start. Okay, let's start with, we've learned a class. We are learning an abstraction. What is an abstraction? Abstraction refers to using simplified classes rather than complex implementation codes to access objects. Okay, and we are going to learn it. It's very, very interesting. I think I was, before the class, I was doing some reading on how to simplify tests. If I can find it, I'll show you how abstractions work here. Okay, so you appreciate it more. Let me see. Let me use Brave browser here. Cool. Where are you? 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 Okay, good. Found something that relates to what we are about to say. Okay, now look at this code here in Java. Okay, just like C++, we declare the data type integer. We declare we label the box. Okay, maybe we are creating what do you call it, a space to store your information. So I have to label the box that this box is for maybe shoes. This was so that's the name of the hot, the memory location A. And what have I placed inside? 10. I declare another data type for God's sake. They are all integers. Oh. They are all integers, and I'm declaring different data types for all of them when they all have something in common. And please, who can clearly unmute the mic and say, what do these things have in common at the end of the day? What do all these things here have in common at the end of the day? I want somebody to just unmute the mic. Oh,
Integers,
this is what they
numbers.
have in common. They are all
They all
integers.
They
have
have
So if they are all integers, very good. Why don't I create a class that they can all exist in as integers? And that is where, like for instance, with an array, okay, I just declare an array and drop all of them inside as integers. Okay, and then this array assembles label to them that the first number here is labeled as 0. So whenever I call upon 0, okay, it means 10. Whenever I call upon 1 from the array, what has been saved in 1, 20. Whenever I call upon 2 from the array, what has been saved in the memory location 2, the number what, then I can perform what some calculations with it because I have placed them in a class and they are easy to access instead of now creating different memory locations for it. Please, I hope you can
can you
relate to what.
yes, please,
Can I
can you
come
scroll
again?
up so we look at where you declare.
You see, integer, I label the memory location as A so that whenever I want to call upon what is stored there, I use the name. We did something like this in C++. Okay, then I stored inside that variable 10. Okay, then I come integer again, B 20, integer again, C 30. I really. Okay, so now we look at abstraction and we say that what is abstraction trying to say? Abstraction refers to using simplified classes. Are you following? Rather than complex what implementation codes to access objects. Okay, so now look at it. I place all of them here together. You don't really worry yourself about this. You will learn how to type this, what each word here means and what they are used for. Are you okay? For now, just look at the sentence and appreciate what I'm trying to say. Okay, so imagine if this was a class and I place all of them inside this class here. Okay, calling upon them will be easier because now I place them in a class, and because it's an array, it has labeled each number with like it's like think of it like a box. When you go to write exams at BAM library, we have like a box where we store our things inside. Are you okay? The thing inside the box has nothing to do with the box number. All right, maybe your box number is maybe 1. When you go to 1, it's not guaranteed that when you open the box, it's 1 that you are going to see inside the box. Please, do you understand? So it has been labeled as 0. It starts from the labeling starts from 0. So the 10 has been labeled 0, the 20 has been labeled 1, and in that order, the 30 has been labeled 2. So whenever I call upon 2 from this class, okay, I'm calling upon a particular number inside that box, and that is 30. Please, do you understand? It makes this code implementation easier than instead of like writing all this when everything can be done like this. Okay, that's what I mean by abstraction. Please, do you understand what I'm trying to say?
yes, Amen.
Okay. So that is what I'm trying to say. So abstraction, it will get to a point. Somebody will help me to pronounce this word. Yes, I'm saying it before we get there. So please, those who can pronounce it, start practicing. Okay. The last time Madam Vida helped me with this studio code. I'm getting it right now. So please, those who can pronounce this one, all right. start practicing because I'm not going to pronounce it. Maybe Tina others friend. I'm telling you the truth. Yes, I'm saying the truth because why? Why? What is this
I'll
one?
help you.
Please help me. I'll be grateful. Sometimes you have to admit when you can't do something. Don't stress you. But people will laugh behind the scenes. Yeah, so I'll say it. So I'll not try. Okay, so often it's easier to design a program, okay, when you can separate interface of a class from its implications. Okay, so if I'm able to separate this, let me go back to the code I was working with. Okay, if I'm able to separate this guy from its interface, what am I trying to say? Let me hide. Oh, down too much. Okay, as I said, if you go into BAM library and you put inside the box, they give you a particular number, okay, with a key or so attached to the number. When it comes, you look at them. I think the number is 2. They take one for themselves. Or I've really forgotten how it works. If anybody remembers, you can help out. But what I say is that what you put inside the box, maybe the number on the box is 888. That does not mean that what you put inside the box is worth 888 Ghana cedis. Please, you understand? So, in other words, separating interface, okay, of a class from its implementation is what I'm trying to say. Interface is what we are seeing, okay, but what it implies is different. Okay, so if I'm calling up on the code, I called upon in the area, I called upon 0, and then the 0 ended up being 10. Okay, I mean that the box has been labeled 0, but what has been stored in the box is a value 10. Okay, so even though I called upon 0, my outcome out of my multiplication or my addition or something, nothing to 0. The 0 that I called on, that's because I called upon something, but that something implies something else. Are you okay? I called upon maybe you went to the box labeled 0, but that does not mean that when you go to that box, there is nothing inside the box because the box has been labeled 0. Are you okay? What has been stored inside implies something else than what you are seeing on the interface. We should take note of that when we are talking about what abstractions is very, very important. Are you okay? When we say something is even abstract, like I think about it. If I say I am sad, okay, I can be having a smiling face on, okay, and emotionally I might be sad. So the fact that I'm having a smiling face on my interface does not mean that I'm in, like I'm trying to yes, I'm just trying to put onto your face as I'm standing in front of you that, oh, I'm happy. But deep down inside me, the implication in me might be that I'm sad. We are all classmates here. I don't want to use this kind of words here, but we are having a class, like a group discussion. Okay, if I tell you right now, you don't know me that much. If I tell you that, oh, so I say Fio, okay, Fio, the way you will take it, or my screen is getting dim because I'm running out of battery, but I'll connect it very soon. If I say Fio, maybe you will take it offensively, put a smile on your face, and then never talk to me again. But what I saw, all right, and what that, oh, we have all been there. What I said is not what I actually implied because people misinterpret things. Okay, if you can relate on my level, I like you understand what I'm saying. I can say something, and the implication of it might be taken differently. I can say something right now, but how it will refer to each one of you might be differently, might be taken differently. Let me put my words right. They might be taken what differently, and that is very, very important. That when you're working with abstraction, you should know. Who say on the interface there's 0 there, but anytime the person clicks on 0, this is the outcome. That does not mean that there is so does not always mean that there is something wrong. Maybe that thing implies something else. You have to find out what it implies. Okay, when I click on this button here, all right, and I say record, my camera should just start all of a sudden, and I'm recording that video. But look at the things I'm seeing. If I'm not seeing all this thing here, the fact that record button on your phone means start recording the video or start recording yourself or whatever. Does not mean that it will imply the same thing on this interface. Please, are you getting what I'm trying to say? Hey,
Yes, sir.
reactions are not coming, but let's continue. So, okay, in object-oriented programming, you can abstract the implications details of a class and present a clean, easy to use interface um, through the class member function. So I can hide, as I said, you can say something, I will put on a smiling face, but deep down inside me, I'm offended. Okay, so I can hide the implications, okay, but make the interface known to you. After all, you the program user, you are working with interface, but what is going on behind everything, okay, you just have to understand it, but you don't really have to see it. You don't really have to see the code, but you have to understand what the implications are. Please, do you understand? So the whole concept of abstraction it also helps us to isolate. Okay, we also help us to separate what interface is and what implication is. And I think I've spent enough time trying to explain what an interface is and what an implication is. Me, frankly speaking, these are terms, okay, that we if you sit down, you can read them, okay. But the actual problem, okay, is what I actually prepared slides on. And if I should take you to it for you to see what we are going to, you will see that wow, if you really missed C++, you have missed something. Okay, because most of these things are like almost the same. Almost. I'm not saying they are exactly the same. Okay, they are almost the same. You have to declare a memory. The rules in labeling, giving a name to a memory locate a variable, like they are the same. Camel casing, if you remember, all of it, those kind of terms, they are the same. Okay, what is a character? What is a boolean? What is a double? What is a float? Long, integer, short, bytes? They are all almost the same thing. Okay, you can see the way this thing was declared. The data type was declared, then the name of the variable was what, or the container was declared, then something was placed inside it. Okay, but what was placed inside it must must qualify or also fit with the data type, because I can't write string here and I come and put something that is not in quotation marks inside here. All right, it will not work. It will conflict. The coding it will not compile. Let me put it that way. Are you okay? So we are going to come across all these things. We are going to learn about operators, arithmetic operators, plus, minus, multiplication, division, modulus, increment, and then decrement. We're also going to learn about comparison operators. Okay, this is comparison. It's different from assignment operators. If you remember from C++, okay, this is equal to, okay, equal to in the sense that I'm trying to say that I'm comparing what is at the left side and what's at the right side. If they are the same, okay, not that what is at the left side should take what is at the right side, like what we see here when we ask. That's an assignment operator. Okay, I've assigned into this container here, okay, this number using this what assignment operator equal to, okay, that one's assignment. But comparison means what is here, is it the same as here? So it will return true or false. That's what we mean by comparison. When you compare something, it's not the same, it's false. If it is the same, it's true. Are you okay? So you can see that they return true or false, false, true, true, false, in that manner when the comparison is done. Is this greater than it? If so, return this. Logical operators like what we did, and, or, and what, not. Do you understand? So not equal to. We are going to have a lot of fun because it's going to be like revision. Are you okay? It's going to be like revision of our C, but just a little bit more because there's something called bitwise operators. We are going to learn all these ones. Okay, Java is a bit, it demands a lot more than C++, but we will be fine. Okay, we also have the ternary what operators. We also look at that. Okay, then we also have the instance of operators. Okay, we are going to look at all these things. Okay, so be preparing yourself, prepare your ID. Okay, read these terms. The next time is fast running, and I want us to give the space of asking questions and all. So read these terms to your best understanding. Ask questions, DM me, I'm not like always available. I will not say that because my work demands that I put my phone aside and work. Okay, but when I as of when I see your message, I would attend to it with mass seriousness. Are you okay? So you can DM me. Oh, I read this. I didn't really understand it. Can you help me out? I'm always a tester with you. Are you okay? Now we have gotten to this. The person who said he's going to help me with the pronunciation, can you please do the job you pledged you would do? Please come again.
Encapsulation.
Encapsulation. Encapsulation. All right. So this is the process. This is the process of providing a public interface while hiding the implementation details. Okay, so we learned that abstraction, okay, abstraction refers to simple classes rather than what complex implementation code. Remember the difference. It is the simplification of what classes rather than using complex what implementation codes, abstraction. Okay, abstract. Whilst let's go. I'm waiting. Whilst thank you is the process of providing a public interface while hiding the implications, okay, or implementation details. And this process is known as what? The encapsulation. Okay, so yes, I've tried. We will specify a set of a set of what public what methods and hide the implication details. We are going to do that, and I stated that with even with the arrays. Okay, you are going to see an interface. Okay, but you know that when I see a zero, inside the zero has been stored inside the number 30. You are going to enjoy it. Other programmers on your team can then use your classes without having to know their implementations. Yes, this also comes to draw my memory back to calling upon libraries. I don't know if you remember C++ include IOStream. If you remember, you don't really know the set of things actually being implemented in the IO streams. We know that it helps us to see out, see in, and all that. But do you know what code has been placed into that see out that you just read? What it actually implies? No. You just use it because it has been made simple. This process is what we call as the let's go and capsule. Whatever the one. Okay, so I hope you get it. If you get, please give me a thumbs up. Okay, so we create a class in C++, we mean a library. Okay, inside that library of usable things, okay, that we can usable terms that we can use, but we have hidden actually the code. Maybe if I ask you to have type the actual code to see out something, okay, the actual code that goes into seeing out something, okay, it would have been maybe a lot. Okay, but they have made it simple and then there's giving a term to it as see out. Whenever you type see out, you are using or fetching the implementation of that code and using it that the computer reads and know that okay, whenever I see this, I should use it. How did I know that whenever I see the term see out, I should display out something to when it goes to the library and find out the meaning of see out and then the code that goes into it and runs it, you know that okay, I'm supposed to display this. And the process of hiding this code, okay, to a user, okay, or maybe even sometimes to you, as I said, they said programmers, okay, in your team may use this what these classes, okay, but they don't even know their implications or implementations. Are you okay? How were they implemented? You don't really know. Do you know how? Who can help us by help and telling us what see out? How is it implemented? All we know is that when I type see out, okay, I'm trying to see out something to the console, right? But who knows the actual implementations? Good, because we know that we took it from a library. You see, you can see some books here. Just trying to refer to this, okay, but it actually appears on almost every slide. But look at it. It's like the books is the library, okay.
Then I just pick out a term, okay, from the library, and I type it here. Okay, maybe see out. But when a computer reads, it goes to the library and finds out like a dictionary, find out what's the meaning of see out. See out is this, that. It means read out this. Then the computer understands it, then comes out and executes that for you. Do you understand? But you, all you know is that see out does this. Please, are you following? That is what we call as the encapsulation. Huh? Yes, at the end of everything, I've been able to say it. You can't hold it against me. Let's go. So we also have inheritance. In object-oriented design, inheritance is a. Let's not even talk about this one. Let's come to we as human beings. When I say inheritance, who understands inheritance? Like in your own term. In your own term. I like the way people are giving me answers and all. It really helps the class. So who let me move this thing sharp because somebody reads everything and starts telling me answers. Okay, so who can help? Okay, Prince Nana Dark inheritance.
Yeah. Good evening. So inheritance
Good
is
evening.
like gaining ownership of a property from someone.
Okay, so if I get you said giving ownership. I didn't really get you right. If I'm right,
Gaining, not giving, like gaining
gaining ownership.
of
Okay,
a
so
property from
gaining.
someone.
Very good. Very good. That's excellent. Now let's use the words that he used here to explain it before we go back to reading it. When I say I gain something, it can be two things. Either I worked for it or it was just given to me. Please, we all agree. If you don't agree, raise your hand. Let me know that you don't agree. If you agree, give me a thumbs up. Let me know that you agree. That when I gain something, it can be two things, can imply two things. Either I worked for it or it was just given to me. Good. Daniela, thank you very much for agreeing. Daniela agreeing quite a baby alpha. Yes, Nora, thank you. Abuaje, thank you. All right. So we have I will not say majority carry the vote because I'm not seeing majority reactions, but still we have agreed to the fact because I'm not seeing any hands. Vida, thank you.
Royal Blue.
Charles, thank you. So if I am gaining something, it implies these two things. Inheritance. So first of all, it's that I am the class others are picking from, and they are using me. What is found in me? They are inheriting from me. But in other words, I worked for it. I worked for it to have what I have. It can also mean that I was given. Well, that's one fun thing about the code. It also means that I actually also didn't work for it, but I also took it from another class. I'm using it. Another class also benefiting from my end and using it. So when the update is done on the main thing, it affects all of us because we are all inheriting it. I don't want to use sickness in this sense. I want to think positive, but sickness is inherited. It can be inherited. Sorry, I'm saying it's inherited. It can be inherited. We all know that. Some of us have been science students and all. We know genetics. Okay. Some sicknesses can be inherited. Okay. And even if you don't exhibit it, okay, your genes might carry it to your offsprings. Please, do we understand? So I might not make good use of it, or I don't say good use. I might not make use of it, or it might not affect me directly, but it is in me, but it will affect whoever picks from me. Okay, so inheritance is one fun. If you understand it, okay, you can manipulate it to your advantage in so many ways. So in object-oriented design, inheritance is the relationship between more general classes. The word is more general classes called the super classes. Okay, called the super class. I'll ask questions on this one. And a more specialized class called the subclass. As I said, it can be that
Yo, boss, I can't hear you. I don't know if it's just me. Freeman.
See, he said his machine was low. Maybe it's off.
Yeah, hello everyone. Good evening. Freeman will be back with us soon, so let's be patient and give him a few minutes. Yeah, Mr. Frank Ajeku, your hand was up. All right. Hello everyone. For now, you may unjoin the meeting and then be on standby. We will notify you on the paid participants platform if Mr. Freeman is ready to go again. So to not waste your time or your data. For now, please, you may log out or you may sign out from this meeting. And then when he is back and is ready, we will notify you as soon as possible.
All right, sorry, my network went off just like that. I don't know what happened. Just went off like that. So, but I'm back. Okay, and I can see that some people are running away, but we are almost done here. Okay, for what we are supposed to. I prepared for us to learn today. So inheritance, we are talking about subclass and superclass. Okay, super in the sense that even if I'm talking about, let me use this interface. Okay, okay, this interface will not help us. I wish I've opened Microsoft. We know superscript and subscript. Okay, all right. So in the sense that one goes above a given test and the other goes below it. Okay. So if I am a super class, okay, what am I? I am the one that I worked for. I'm trying to use normal human. This one. I worked for everything that is to be gained. Okay. And then I am the one doing the giving based on what instruction has been given that I should do the giving, or others will come and do the taking. Please do you understand? I become a super class. Please do you understand? So a subclass inherits data and behavior from a superclass. Okay, inherits is in what way? It's that the superclass gives it out per the programming, or the subclass comes and fetches. Please do you understand? Is understanding achieved? Good. So it's either the superclass is giving it out or the subclass is inheriting it by taking it. At the end of the day, there is an inheritance because we established the fact that inheritance has to do with either is being given to you or work for it. Do you understand? All right. So that is that. Let's come to the next thing on the act. If I focus my phone, please give me a moment. Okay, let's continue. Let's continue. So let's look at the next thing. We have established what superclass and this one is. So for example, every car is a vehicle. Obviously, every car is a vehicle, but it's not every vehicle that is a car. Let me put it that way. Okay. Every car is a vehicle, but it's not every vehicle that is a car. This, do you understand? Okay, so cars have the ability to transport people from one place to another. The class car inherits from the class vehicle. In this relationship, the vehicle class is the super class, and then the car class becomes the what? The subclass. Okay, it is inside or getting its inheritance from the super class because generally the general terms given to a vehicle. Okay, who can tell us that we have a picture here to even assist us? I don't know why. Let me zoom it in a little bit so that we get what we are talking about. Okay, so what are vehicle? Everything we are seeing on this road here is a vehicle. It's a vehicle. Okay. But it's not, as I said, it's not every vehicle that is a car. A motor can be on this road. It's a vehicle, but it's not a car. Please, do you understand? What others? Give me more. I'm not really a big fan of other things that are carrying people apart from very good, very good. So what's the name? Abubuya. Abi, is it Pragya? Yes. Pragya, yes. I'm trying to relate, but they're laughing at me. Okay, what I'm trying to say is that okay, as long as even if it is picanto, as long as it's moving people, okay, it is classified as a vehicle. All right. As long as it's able to move you, okay, by you operating some mechanics or whatever, it's a vehicle. This you understand. But the fact that it is able to move it does not mean that it's a car. It can be a motor. It can be pragya. It can be what? Give me more. It can be a pickup, pickup, pickup. It can be a truck. It can be a cultivator, like harvester. At the end of the day, when the farmer sits in the harvester and is harvesting, he does not stay at one place. Do you understand? Like the harvester moves on the entire field to harvest what the crops, and that is movement. Okay, and moving from one place to another has been achieved. But does that make it a car? No. Okay, good. So it's like as a class, a sub, like in sets. I was trying to bring it to maths. Okay, the fact that we are all belonging to the unit, universal set, as in we are all in one class, does not mean that we are all studying the same subject. Some of us study both subjects. Okay, some of us study a subject only. Okay, but at the end of the day, we are all in one class. Do you understand? And then that one class represents the super class that we are all inside. But the onlys are the what? The subclasses. Okay. And even sometimes the intersection is also a subclass. Do you understand? It's not even it's a subclass because it is not the main thing that others are inheriting from. Okay. So it can be a super class at the same time. It can be a subclass. Why am I saying it can be a super class? Because others are inheriting from it. As long as others are inheriting from it, it's also classified as a super class. Please do you understand? So the point at which two people are studying, somebody is studying two subjects at the same time means that the person is inheriting from here, is also inheriting from here. Please do you understand? I hope you get it. Right. So where they are inheriting from also becomes their super class. Are you okay? But those that are learning the only are inheriting from their main super class. Okay, so they are also classified as subclasses. When others are inheriting from them, okay, they also become super classes in some way. Are you okay? So that is what I'm trying to say. So we can look at this, look at all these things are vehicles, say a truck, a car, a motorcycle, they're all vehicles, but it's not all of them that are car. When it comes to the level of a car, they're talking about what certain brands like what SUVs and this sedan, whatever. We can talk about, yes, give me cars, types of cars out there. Cast lovers. I know there are some there are males here. Some of the even females are sometimes nowadays getting interested in cars more than even with the males. So can I get some more cars here for the purpose of the class, not for anything? Yeah. Anybody can help us here.
J thought that she momentum.
That's right. Okay, give me more. I don't know what that is, but it's good. That's the example I'm looking for. Yes. More. Okay, we are not getting more. So that's the only car plus the ones that we have. Those are the only car brands out there. Okay, that we can work with for now. So I hope that has been explained. Okay. So inheritance allows designers to reduce, and the reason I didn't even use the word reuse, I'm using reduce, is because when you are reusing codes from places that has already been written, okay, it's going to prevent you from retyping everything again, in turn reducing the code that you have to type because you're just going to pick instead of retyping everything. Are you okay? So when you are reusing something, okay, you don't create it all over again. The thing has already been created, like libraries. Okay, they have already been created. They just go and call from them. Okay, without even knowing the implementations, which is known as, and Vida mentions the word. They are still waiting.
Encapsulation.
And capsule. Yes, and capsule. That one. Yes. Obviously, I can't pronounce it, even though I practice behind the scenes. But yes, let's go on. Should we go on with all this because we are left with 2 minutes? So if I can open room for questions to be asked. Okay. I'm sure these items I'll hand it down to Mr. Evans. Okay, and it is going to be shared to those here. Obviously, I don't know what is going on. I know that for whoever I'm teaching here, as somebody who has is qualified to be here, so this materials will be shared for you guys. You read through, okay, DM me if you have any challenge as well. But this is what we'll be working with most of the time because it's like just like a summarize of what you'll be doing in the coding environment. When we talk about operators, comparison operators, and all, we'll just use this interface to explain everything. Are you okay? So it will be provided to you just to read through. Okay, any questions so far? Any questions? Hey, you're okay. You're okay. Wow. Wow, Vida, yeah, okay. Wow. Okay, that's nice. That's nice. Okay, so if we are all okay, then this is the point where, and you are not going to ask me questions. Okay, as I said, inheritance is when it is given to you or you decide to take. Please do you understand? So since you are not asking the questions, okay, and it's a give and take class. So since you are not giving me, then you have to be taking. Okay, so I rather do the asking. I hope I'm allowed. It is fair. I gave you the chance to ask the question. You said you are okay. Okay, so now I'll be doing the accent. Find out why are you laughing. I'll be doing the accent. So please, don't leave the class. Respect yourself. Don't leave the class. Oh, please hold on, man. Hold on for me. Okay, so let me do the accent. Since nobody is doing the accent, I'll do the accent. Okay, so question number 1. Okay, let me stop the sharing so that people will not get the answers. Probably they have opened the slides on your end too. But at the end of the day, I'll be looking for the way you present your answer, not really reading it out for me, because I've read the slides. So if you read it out to me, I'll know that this one there is slides direct, like slides that you have inherited from the slides. Okay. And you are not really giving your bit of understanding of what has been taught. So I will ask this first question. Okay. Trying to get, I've set the questions here, trying to get them. PDF, 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 PDF. Hey, where questions need run now? It's like the questions have just disappeared. Actually, it's extremely good. Don't give up on me. Lady, why am I just shouting down on me like that? Give me a moment. Let me plug this thing. Why it gives up on me? Okay. Okay, we are back on track. Okay, so my first question is, what is the difference between object-oriented analysis and object-oriented design? It's an examinable question, though. Oh, Bianca, sir. And am I muted? Oh, I'm not muted.
So object oriented, um please, you said what and what?
Object-oriented analysis and object-oriented design.
Okay, so object
Please,
oriented design is developing objects and
is it object-oriented analysis and design or object-oriented design and modeling?
So object-oriented
so
analysis
it,
and
it so
object-oriented design.
you said is developing an object system model.
Okay.
Just what you said, I wrote it down.
All right.
Oh, please, is that not what you said?
Please, I'm like I'm listening. I'm listening to the difference between object-oriented analysis and object-oriented design.
I wrote only one.
Okay. Thank you. Right. Please, is that all your submission?
Yes, please.
Okay. Okay. All right. Abuaje, friends.
So object-oriented analysis has to do with the sketch or the
Okay.
model of the application to be worked with, and then the object-oriented design has to do with developing it, putting it into use, kind of way. Thank you.
Okay. Okay. Anybody else another submission for us?
Let me see. Object-oriented analysis is like solving solving the problem, like thinking about the problem. Whilst the object-oriented design is how will you solve the problem, like how you will design it.
Okay. Okay. Alpha. Alpha. All right. So you guys have done so well. Okay. Your bits. I can see you're not reading. You're not inheriting from the slides. Okay. So I will also give my bits, and you can judge. I stand to be corrected. You can judge whether what I'm saying is true or false. Okay. From your understanding. So an object-oriented analysis, okay, is the study or you study the problem and list the objects that is needed. As I said, when I'm analyzing something, okay, I have to first study the problem, then list the things I will need to solve the problem. Are we okay? So it's like creating a model, all right, of the possible solutions to the problem. Are you okay? Then the object-oriented design, okay, plans how these items that are needed to solve the problem will work together to solve the problem. So how will I say something is working? I'm designing it. Okay, if I'm designing it, I have to put this piece to this piece so that this problem that I was facing is solved. I have to put this piece to this piece so that this problem that I'm facing is solved. And that is also another form of modeling. Okay, even though both of them are two different concepts, at the end of the day, they model out something. What do the object-oriented analysis model? They model by providing a list of the objects I will need to solve the problem. Okay, so I first identify the problem, which goes into the analysis as well. Okay, even the art of identifying problem, sometimes it's a model. Yes, if you think about it deeply, you realize that you should be modeling something, because how can I solve a problem if I can't actually fit myself or make the problem realistic to see what is going on? Okay, so making a problem realistic to see or fit into it and know that this is what the problem is and this is how best I can go about solving it. You are modeling out something. Please, do you agree to that? So, okay, for the chair, the broken chair, I will need a new plywood. We are listing the objects that you'll be needing. That's why they're all object oriented. I will need a new plywood about this size, about this size. Then this is what goes into the object oriented design. When you plan how the nails will work together with the hammer to work together with the wood to solve the problem of the broken leg of the chair, that is object oriented design. Please do you understand? And let me throw in the object oriented what programming as well. This is when you actually write the program using the objects available. Okay, this is when you write the program using the objects available or given to you. Okay, so what are the objects given? It was from the list, object oriented analysis, the things you need. Please, are we okay? Object oriented analysis like provides the list of what you need to solve the problem. Object oriented design tells you how to use these things on the list, whilst the object oriented programming actually puts the thing into action. So pick up the hammer, hit it, hit the nail into the wood. Object oriented what? Programming. You are programming it to do what it's supposed to do. Design. Okay, at the end of the day, the hammer must enter the wood this way. It must be inclined. You are designing it. Please, are you following? It must not enter it straight. It must enter it inclined. When I am programming, I follow these things that you have designed. You have object-oriented designed to do the object-oriented programming. So that's why the lecturer said somebody can pick an object-oriented design. A programmer, when you pick an object-oriented design, you should know how to program it. Because in other words, it's like in C++, it's like an algorithm. Please, do you understand what I'm saying? So what did we say in C++? What an algorithm is? It's like it always starts with a verb. Do this, do that, do that. So as a programmer, when I pick it, I do that, and I do it, but I write it as a program. That's object-oriented programming. Do you understand? Object-oriented analysis, the items I will need to solve the problem. They are just trying to put it in practical lives. Object-oriented design, what I'm going to do with these items. Object-oriented programming, do what you need to do with these items to solve the problem. Please, do we all relate? Okay, thank you very much. Now, the next one I'm going to talk about is what is an object in the first place? What is an object?
So you said object is an entity in the
Okay,
software
okay,
system.
okay. That's true. Prince. That's very, very true. Prince. Please, you can come into a submission as well.
Yes, so simply an object is a member of a class.
Okay, so an object is a member of a class. Okay, right now I've entered a class. Okay, it's true. All that I said is perfect. It's a perfect answer. Okay, it's a member of a class. Okay, it holds. What does it hold? It holds attributes and it also holds operations. Okay, I've entered a class. What am I doing in a class? I belong to this class because of some attributes I'm holding. Please do you all agree to what I'm saying? I can't just enter a place if I have no business over there. So I can exist in a place because I hold certain traits that allows me to exist in a place. And holding those traits can come from a super class. And that is why I'm able to exist there. And that's called inheritance. Please do you understand what I'm trying to say? So an object is an entity, but we should also know that it holds something to be able to exist in a class, as Prince was saying. Okay, it must hold operations and it must hold attributes. What do I mean by operations? Okay, these are like methods. Okay, so in practical life, let me use this as an example. Okay, like a car. A car holds a color. There's no car without any color. Do you all agree to that? So if I've created a class of colors, won't the car inherit a color from there? Right? We agree to that. The car will inherit a color from the class of colors. Very good. Now I've also created an operation. How does a car operate? It should be something that should be able to move and transport individuals. So if I've created a class that's consists of things that are supposed to be able to move things and so on, the car will also inherit from that class. In the sense that that class talks about the operations of how a car is supposed to operate. That's what I mean by operations. Yes, it holds an attribute, a color, because you identify something by its attributes. Are you okay? And then we will know its action by its operations. What it is doing at the moment, okay, tells us its operations. Okay, and how it looks like also tells us its what? Attributes. Attributes of God. Let's go. Let me use it to explain. Attributes of God. Oh, people. Let's help ourselves here. Attributes of God. Or mute and just say something.
Number, please.
On attributes of God. Did you say attributes of God?
Yes, please. Attributes of God. We are working with attributes. I'm saying an object is an entity. You said it exists in a class, right? So to exist in a class, okay, that entity should have an attribute and it should have an operation. It should have something to do in the class. Do you understand? And if it's not having the attribute of the class, it can't exist in that class. Please, do you understand me? So please, we are saying attributes of God. Let's give some attributes of God right now.
All knowing.
All knowing. Good. Let's work with all knowing right now. Joshua Peter, you're also saying something.
Omniscient.
Very good. Omnipotent. These are attributes of God, not attributes of a human being. We are able to identify it as a God because this attribute fits a God. Do you understand? If I say I am omnipotent, I'm omnipresent, is it possible? Am I at where you are right now? No. Okay, so I therefore don't hold this attribute, so I don't fit to be called a God. Please, do you understand? So therefore, if I'm found operating as a God and I'm lacking these attributes, then it does not fit. So an object is an entity that exists in a class because of one, the attribute it is holding, and two, what it operates in that class. If it has no business in that class, like a string, if it is not a string, it can't exist in that class. Do you understand what I'm saying? If I declare a class of strings and you are not a string, or you don't operate as a string, you can't exist in that class. That means I have to create somewhere else. Okay, you inherit from that class, but when it comes to you, it changes to your nature because of what you are operating or your operation. Do you understand? Object is an entity. Abuaje said it exists in a class. Very good. These are all perfect answers. But let's understand the fact that what is it doing in a class? What is that entity doing in that class? One, because it holds certain attributes to exist in that class. Two, because of its operations, what it does in that class. If it has no business in that class, it shouldn't exist there. If I have no business among gods, I can't say I am omnipotent. I can't say I'm omnipresent. Do you understand? If I don't operate like a god, I hope the understanding has been cut across. Very good. Next question and the last question for today, then we end everything. Okay. The next question I'll ask is what principles? What is abstraction? What is abstraction? What is abstraction? Ayeka, nyankasa o. Okay, Awadi. Awadi, please, you can unmute and speak now.
Yes, so I said it refers to providing
It
public
refers
interface,
to
providing a public interface while hiding the implementation details.
very good. So if you are picking what Abuaji just said, we are saying that abstraction means showing only the important details, okay, and hiding the rest. Abstraction hides the rest. It's not that it's not really that important, but it only shows the important details. Are you okay? Let me try. I've stopped sharing my screen, but I'm sure you guys have hovered over something before. When I compute, when I say to use your mouse cursor to hover over something before, you know what I'm talking about. Sometimes when you hover over something, a button, the button has a word on it. But when you hover over it, it gives you more information about what that button does. Please do agree to that fact. If you're a big fan of clicking buttons, you know what I'm talking about. Even a link, sometimes you just see a word or so, but when you point that word, okay, you see a whole string of links. Whole string, you don't need to know it. It's not important. But that word or that button, okay, it serves as an abstraction to what needs to be actually done. Please join us. It's like an abstract of the real thing, because we know what abstracts are. Abstract things are not really real. Do you hear what I'm saying? They're not real. Please do you understand? So example is when you drive a car, for instance, okay, when you drive a car, you only use the steering wheel and the pedals. You don't see the engine's complex parts and what they are doing. Please do you understand? When I'm driving a car, what are the important things I need to be able to get to my destination? Okay, that is what I'm talking about. Okay, so I sit in a car, I put on my seat belt. All right, what do I need? I need a steering wheel, and then vroom, the gas, my uncle, then the brake. That's all. That is all I need. Okay, but whether the engine, this one push this one, the oil here first, and me find that shit. But actually, it is important. Is the reason why the car is moving, right? But to know it, is it important? No. Do you understand? It does not contribute to where I'm trying to get to.
Hello. Hi.
Yes, sir. Yes, sir. You have a question.
Yes. So please, can we say encapsulation is the same as abstraction?
Abstraction. Good. It's very good you have asked that question. Now let's come to encapsulation so that I clear this. Encapsulation means keeping details inside a box. Listen, okay, it means keeping details inside a box and only giving people the buttons they need. Example. Let's take example. A TV has buttons for power and volume, right? You don't need to know how the power circulates when you click it. So encapsulation and abstraction, literally on a basic level, they are the same thing in the sense that they all hide something. Please, do you understand? Do you understand what I'm trying to say? But abstraction is you are covering the work that the thing is doing, how the engine is moving, pumping the fuel and burning it and things. When I hide it to you, and all you need to know is step on the gas and then go. Use the steering wheel, turn it to the left if you are going to the left, and so on. That is abstraction. Do you understand? I'm not giving you the real details of what is actually going on. Encapsulation is I also hide that details in something like a box. Like for instance, the example I stated, that a TV has buttons like power button and a volume button, but you don't need to know how let me say the circuit, how the power runs through the circuit. Right, when you click on the power button, or how the volume code is implemented by the television when you press the volume button. All right, so we are right. Abstraction and encapsulation in one way they are the same, based on the fact that they are all hiding something. Do you get what I'm trying to say?
Yeah. So let's say the example you used earlier on, when you
Yes.
give the cout command.
Yes, please.
That command, is it encapsulation or abstraction?
Good. So that command that's like the cout. Okay, let's it's good you have brought this one inside. Now, what is the cout? First of all, what do you know what the cout actually is? What it actually implies?
Is
You know.
to print out their
Okay,
output.
so at the end of the day, you want to print out something. So all you know is that you are obeying the rule that, well, me, what I need is I want to print out. And I want to print out something. All I need to type is what? Cout, right? Right.
Yes. Yes.
Good. So at this point, what is going, is that encapsulation or an abstraction? And I'm saying that for an abstraction, I am only showing you the important details of the thing. Look, oh, I am hiding something, but I'm also showing you something. As I said, I show you the important details and I hide the rest. It's not like encapsulation that actually hides everything. It just provides you with a button. That's why I said with abstraction, when you hover over something, they might give you some something you know more about it when you hover over a button. But encapsulation is the button. I don't know if you are getting what I'm trying to say. So in a cout example, for instance, okay, when I type cout, okay, what have I done in the first place? I'm just trying to print out something to the console. Okay, as a computer user on my end, okay, an abstraction has gone on, because when I come to the screen and then I see enter your name, what do? I enter my name. Whether the name is going to be due to what I don't really know, but a detail has been shown to me that for this particular space, I am entering the name. Please, do you understand? Encapsulation comes to you, the programmer. When you are using the cout, do you know what is inside the cout? It has been totally hidden to you in a library, right?
Yes. Yes.
Please, do you understand what I'm trying to say?
Yes, I get you. So like a simple example would be like the Teams we are using right now.
Yes, please.
Let's say the mute button. When you hover over the mute button, you see a message, mute mic, or
Good.
the
Good.
shortcut, something like that. That is what's the name?
Abstraction.
Abstraction. Yes.
Because
But
some
then
amount of
clicking on the
detail has been
button
given to
itself,
you.
yes. But
Yes,
then
some
clicking
amount
on the
of
button,
detail. Yes, you are right.
all right. So clicking on the button to perform the task itself is where the encapsulation comes in, because we don't know the code in there
Good.
that makes the command
Thank
run
you.
or something like that. Okay.
Thank
Fine.
you. Very good. So in basic explanation, abstraction shows you only what is necessary and hides the rest. Do you understand? When you are driving a car, what do you
Yeah.
need?
Yes, the
The drive.
paddles.
Very good. Do you understand? You don't need to see the engine's complex parts. It's not necessary. So only shows you something. Do you understand?
Yes.
So in programming, you use you use a method like print, okay, without knowing what or how it works actually. But all we know is that the word print has told us something about what it does. Do you understand? Yes. Please do you understand the word print?
Yes, please.
But encapsulation is I have hidden the details of like actually how the word prints work. So when I put the data and methods together into one box, okay, and protect them, I have encapsulated it because nobody sees it anymore. Do you see the data and methods that see out goes through before it's finally sees out something to the user? It has been protected from your eyes, right?
Yeah.
But the abstraction being made to you is that you know, even though it is hidden, you still know that what? When I use the see out, what am I supposed to come out with? A message to the console. Do you understand? The encapsulation is the actual thing being hidden from you. Do you understand?
Yeah.
Oh, Vida.
Yeah, so my question is,
Yes,
what's
please.
the difference between encapsulation and encryption?
Okay. Encryption is different from encapsulation. Encapsulation means that look, no matter what you do, you're not going to have access to the
Really?
actual data. But with encryption, I can unencrypt it. Please, it's like trying to make an encryption is like putting an information of something, okay, in a form that is very hard to get access to. That does not mean it's impossible to get access to. It prevents others from trying and trying because the process of trying to unencrypt it is a long process. It's tiresome. So what do? You give up. But that does not mean the information is impossible to get to. In the process of encapsulating something, I can use encryption. Do you understand? That does not mean that encryption is the main encapsulation. Encapsulation is simply just making the thing not known. Just don't make it known. No matter what you do, there is no way you are going to know how see out function is actually working. Do you know? Have you tried? Please, are you getting me?
Yes, yes, but I haven't tried yet.
Good.
I
So
will
in
try soon.
try it. Good. You realize that what they tell you is a library, right? It's a include IO stream. It's part of that library. Have you been to that library? Have you, when you read about see out, what do they tell you? They tell you that it helps to print out an information to they have told you the necessary information. That is what abstraction. You understand? Please do you get it? But encapsulation is that particular thing that has been abstracted, that the important information is given to you, that it helps knowing so that you know what to use it for. You know that you use it to see out something to the user. They have given you some amount of information about how it functions. But the actual thing that built the see out word, do you know it? It has been encapsulated. Please do you understand?
Yeah.
Yes. And I think encapsulation sometimes one way or the other has to do with like being belonging to a particular user and a user alone, like copyright. Do you understand?
Yes.
You can
Yes.
have information about how something works, but whether you know how it was built so that you will use that same methods to build your own, like Coca-Cola, for instance. the formula, they say as they're stipulating out, I don't know whether it is true, but the formula for Coca-Cola is known by who? Is it just one person or two or so? Okay. And that is what encapsulation. Okay. At the end of the day, what is Coca-Cola? We know that it's a drink, abstraction. But what went into building the drink so that others will also copyright it is encapsulation. They hide that from you. Do you understand? They gave you
Yeah.
ingredients on the box, sugar. This. Did they tell you how to apply that sugar?
Okay. Okay, so Freeman.
Yes, please.
So you mean if
Listen.
I get everything right, meaning abstraction is making making complex things simple,
Very good.
whilst encapsulation is protecting an information or something like that. That's
Precisely.
for protecting data.
Thank you. So it has to do with hiding the entire thing actually. Encapsulation is, look, you don't need to know everything. This is what you need. And so abstractions, you don't need to know everything. This is what you need. Do you understand what I'm saying? Work with this. If you want to know how everything was built from scratch, before I gave you this is it, work with it. Then I'm trying to unencapsulate the whole issue for you to know. Do you understand? As I said, I was starting as stating an example with Coca-Cola. When you pick the Coca-Cola bottle, when you go to ingredients, what do you see? You see sugar, maybe carbonated carbonated water. You see color, you see preservatives, but did they tell you how to use these items? If yes, let me know. Maybe that Coca-Cola, I've not bought it before, so that I can start building a company. Because on my child said, put this milligram of this into this, boil it for this. All of it is on the Coca-Cola product. They did that. Whether you still have a question? Whether
No, Freeman. Like, I'm done with my question.
okay, but I hope you get what I'm trying to say.
Yes, yes, I
Good.
understand.
So, just picking a Coca-Cola as an example, I'm trying to explain to you that when you pick a Coca-Cola bottle, okay, what is the abstraction of a Coca-Cola bottle? The items you need, what you need to know about the product, right?
Yes.
Good. But how to use these items has been encapsulated.
Mm-hmm.
Because giving them to you means that I'm giving you my power and you can build this thing and even sometimes make it better, right? That people are
Yes.
going to stop buying mine and then jump on yours. So what do we do to such information? We encapsulate it, providing you with the only thing you need to know is abstraction. Please do you understand?
Yes, please.
So in code, providing you with how C out work is abstraction. You don't need to know everything about C out. But how C out was built from scratch and everything that went into building C out has been encapsulated. Please do you understand?
Yes, I do.
Please, if you all understand, a thumbs up. All of you. So I know that like the time spent on this has been worth it. Very good. Thank you very much. Thank you very much. I like your reactions. All right, so we can call it a day now. Or there's any other question? If call it a day, clap. I like the clapping reaction. Yes. If call it a day, clapping for everybody. That means everything has been well understood. Yes, Father has given me one. Joe has given me one. Yes. Oh, very good, very good, very good. So at the end of the day, we have all understood everything. Thank you very much for having me. God bless you and have a good night. See you next time,
Bye
same time
bye.
next week. Can be behind say